So in this video, we are going to revise atomic structure, which is CC3, and the periodic table, which is CC4. I am on page 10 of your core info guide. I'm going to start by looking at this table. So hopefully at this point, you all know that atoms are made of protons, neutrons, and electrons. You need to know that protons and neutrons are found in the nucleus at the center of the atom. You've got your nucleus here at the center, and then you've got electrons, which are found in shells around the nucleus. Okay, so that's your nucleus at the center, and that contains protons and neutrons, and then you've got electrons in shells around the nucleus. Okay, for each particle, you need to know the charge. So is it positive or is it negative? Protons are positive, electrons are negative, neutrons are neutral, they've got no charge at all. You need to know the mass, okay? You need to know how heavy each particle is. Protons and neutrons both have a mass of 1. Electrons have a mass that's 1,835 times lighter than protons and neutrons. So you can learn that it has a mass of 1 over 1835, or you can learn that it's got a mass that is negligible. And by that word negligible, I just mean that the mass is so light that we don't even count the mass of the electrons. I need you to learn the information that is in this table, okay? Try and learn it off by heart and learn where protons and neutrons are found and learn where electrons are found. And when you think you know it all off by heart, then I want you to answer these questions to test yourself. So press pause now, learn the information. When you think you know it off by heart, answer these questions. When you've got them answered, press play to see the answers. So I filled in the answers. The mass of a proton is 1. The charge on an electron is negative. You can write negative, you can write minus, you can write -1. Okay. The mass of an electron, how heavy is an electron? The answer is negligible, or 1 over 1835. Okay. That number can change slightly. Sometimes you get it written as 1 over 1840 or 1 over 1837. So I just find it easier to learn the word negligible. Make sure you don't write 0. Yes, electrons are incredibly light, but it's not correct to say that they've got 0 mass. What particles are found in the nucleus? You find protons and neutrons in the nucleus of the atom, and then you've got electrons in the shells. So make sure you know the information in that table. Make sure you are able to answer questions based on the information in that table, okay? The other thing you need to know is how many protons, neutrons, and electrons an element might have. And to find out that information, you are going to look at your periodic table. Okay, on your periodic table, each element has got 2 numbers next to it. It's got a bigger number on the top and a smaller number on the bottom. On your periodic table, and this is given to you in the exam, you've got a key that tells you how to read your periodic table. And it tells you, okay, that this big number on the top is the mass of the atom. It tells you that the Be here is the atomic symbol, that this word here is the name, so the name is beryllium, the symbol for beryllium is Be, and the mass of beryllium is 9. It also tells you that this little number here is called the atomic number, and it tells you the number of protons. So I've drawn sodium in my book, and I've drawn it with 23 and 11. And by looking at my key, I can see that the small number here, 11, is the atomic number, and that tells me the number of protons that sodium has. So next to sodium, I'm going to write P stands for protons, I'm going to write 11, okay? The small number is 11, so it's got 11 protons. I also need to know how many electrons sodium has, okay? Neutral atoms, and by that I mean atoms that do not have a positive or negative charge, always have the same number of protons and the same number of electrons. So if your protons is 11, your electrons is also 11. I also need to work out my neutrons, okay? To do this, I take the big number, 23, and I subtract the small number, 11, and I get an answer of 12. So sodium has 11 protons, 11 electrons, and 12 neutrons. If I were to take nitrogen, it's got 14 and 7. So I'm going to write nitrogen here with 14 and a 7. And I want to know how many protons, electrons, and neutrons nitrogen has. Okay, this small number tells me the number of protons. If it's got 7 protons, it's also got 7 electrons. To work out the neutrons, it's the big number minus the small number, and that also works out as being 7. All right, I'll do one more. I'm going to do phosphorus, which has the numbers 31 and 15. I want to know protons, I want to know electrons, I want to know neutrons. Protons is the small number 15. If it's got 15 protons, it's also got 15 electrons. And to get the number of neutrons, I'm going to get the big number minus the small number, and I get 16. If you get confused in your exam and you can't remember whether the small number or the big number is the protons, then you look at your periodic table and it tells you that the number at the bottom is the atomic number and the atomic number is the number of protons. And that information is on your periodic table, which you are given in your exam. I'm going to give you a few to try for yourself. Okay, so I'm going to take oxygen. The numbers are 16 and 8. And I'm going to take sulfur. The numbers are 32 and 16. And we'll also try potassium. The numbers are 39 and 19. And for each of these, I want you to work out how many protons, how many electrons, and how many neutrons you've got. So I want you to press pause. I want you to work that out for yourself and then press play when you're ready to check your answers. Okay, so I have filled in the answers. Oxygen has got 8 protons because the small number is 8. It's got the same number of electrons. And to find neutrons, it's 16 minus 8 also equals 8. Sulfur, the number of protons is that small number, 16. The number of electrons is also 16. Neutrons is the big number, 32, minus the small number, which also gives me 16. Potassium, the number of protons is 19, the small number. Electrons is also 19. And then the neutrons is the big number, 39, minus the small number, 19, gives me 20 neutrons. Okay? It's important that you know how to work out the number of protons, electrons, and neutrons. Okay? It's also important that you know what these numbers are called. That small number there is called the atomic number. And that large number we call the mass number. Okay? You don't even need to learn that off by heart because it's on your periodic table. It tells you that the small number is called the atomic number and the large number is the atomic mass or the mass number. So it gives you that information, all right? So if I were to tell you, okay, if I wrote this in a slightly different way, instead of giving you the elements symbol with the 2 numbers next to it, if I wrote for you that calcium, okay, has a mass number of 40 and an atomic number of 20. Okay, so if I gave you a table that says calcium has a mass number of 40 and an atomic number of 20, and I asked you to describe what the number of protons, electrons, and neutrons that calcium had. Okay, I've given you the information in a different way, but the way you're going to do it is exactly the same. I want to know how many protons calcium has. I look at the smaller of the 2 numbers, which is called the atomic number, and I see that it has got 20 protons. If I want to know how many electrons it has, I know the number of electrons and the number of protons is always the same. And then to work out my neutrons, I do 40, my big number, minus 20, and I also get 20. So don't be put off if you're not given the information in this format, okay? If you're given 2 numbers, one of them will be bigger, that's the mass number, one of them will be smaller, that's the atomic number. Protons is always a small number, electrons is a small number, and then your neutrons is the big number minus the small number, which in this case also ends up as being 20, okay? So make sure you are familiar with that. Okay, I'm going to push on now to CC4, which is on page 12 of your booklet, and it's the periodic table. I've got a picture of a periodic table, okay? The guy who created this periodic table is known as Mendeleev, and when he put the elements into his periodic table, he didn't just put them in randomly, okay? He put them in a specific order. He put elements that have the same chemical properties in columns that he called groups. Okay, so going down, you have got what we call groups. Okay, so you've got group 1, group 2, 3, 4, 5, 6, 7, and group 0. Going across in rows, you've got what he calls periods. So you've got your periods going across, you've got your groups going down. Okay, so if I asked you, if I said lithium is in group 1, give another element that's in the same group as lithium. Okay, other elements in group 1 are sodium, potassium, rubidium. Okay, so any of those would be acceptable. If I said silicon is in group 4, give the name of another element in group 4. You could say carbon or germanium or tin. Okay, I could say sulfur is in group 6. Give me an example of another element in group 6. Oxygen, selenium, tellurium. Okay, and obviously you've got your periodic table with the names of these elements. You don't need to know any of that off by heart. You just need to know that the groups are going down and the periods are going across. So if I picked nitrogen here and I said, give me the name of an element in the same period as nitrogen, I need to know that the period is the row going across. And if I want another element in the same period as nitrogen, I could pick oxygen or fluorine or carbon, okay, because they're all in the same row. If I asked you for an element in the same period as magnesium, okay, that could be sodium, or that could be aluminium, or that could be silicon, because they're all in the same row, okay? So period means the row that goes across, group means the column that goes down. You need to know the difference between the two, because you can be asked to give an element in the same group as silicon. You would need to know that would be carbon or germanium or any of these elements, or give an element in the same period as silicon, and you need to know that you are going across and picking out sulfur or chlorine or argon. Okay, so that's the difference between groups and periods. All right. So I've given you some sample questions down here. Okay, horizontal rows are called periods. Name an element in period 3. Okay, period 1 is hydrogen and helium. Okay, so that's a little bit harder to see on that periodic table, but here on the one that you're going to be given, you can see hydrogen and helium are in row 1, and then row 2 starts with lithium. Okay, that's period 2, and then period 3 is down here starting with sodium. So when I asked for an element in period 3, I could pick sodium, magnesium, aluminium, any of those. Okay. There are some practice questions here on the periodic table. I would recommend answering these questions. Okay, so the first 3 we've gone through. Okay, questions 4, 5. Okay, how many electrons does something have in its outer shell? You get that information from your periodic table. If an element is in group 6, it's got 6 electrons in its outer shell. If an element is in group 2, it's got 2 electrons in its outer shell. Okay. Have a go with these practice questions. Okay, they're on page 12. Have a go. You'll get the answers or model answers up above. And when you are finished answering your questions, come back and have a look at the answers, and I'll go through the answers with you. So I have given you the answers to these questions in your booklet already. It's on page 13. Okay, I just want to go through 8 and 9 with you. If you're asked to write the electron configuration, you need to figure out how many electrons something has. So potassium, if you look at a periodic table, has 19 electrons. Okay, you would be told that. The electron configuration is how many go in the first shell, that's 2. How many go in the second shell, 8. How many in the third shell, 8. And how many in the outer shell, fourth shell, just 1. Okay, so there's 19 electrons in total. It ends up with 1 electron in the outer shell, which is what I'm expecting because potassium is in group 1. You're then also asked for the electron configuration of sulfur. On the periodic table, sulfur has got 16 electrons. The atomic number is 16. 2 electrons would go in the first shell, 8 in the second, and 6 in the third. That puts 6 electrons in sulfur's outer shell. Sulfur is in group 6, so that is what we are expecting. Okay, so remember, first shell can hold 2, second can hold 8, third can hold 8. Okay, and you don't move to the next shell until the shell that you're on has been filled. The rest of these questions refer to the periodic table. It's all about how the periodic table is arranged. And that last question, 15, would be a 4-mark question about how the elements are arranged in terms of the electrons that they've got. Okay, elements that are in the same groups have the same number of electrons in their outer shell. All of the group 1 elements have 1 electron in their outer shell. All of the group 5 elements have 5 electrons in their outer shell. Okay, Also, in terms of the rows they are in, every element in period 2 has 2 electron shells. If you're in period 3, you've got 3 electron shells. In period 4, you've got 4 electron shells. Okay, so again, they're not just put in the periodic table in a random order. They are all in specific places for specific reasons. Okay, so that's CC3 and CC4, atomic structure and the periodic table.